to the major missions of ISRO. Okay, and major missions in the world also I am going to share here. First mission is belong to the, okay, we don't want to waste our precious time, and I pick I need to go with a speed because I have some lack of time issues, so that's why I will pick here speed more. I hope you can get in that speed also. Okay, it is Aditya L1 mission. Okay, first is the Aditya L1 mission, and just observe, guys. You have to remember here, India's first dedicated solar observation mission. Aditya L1 mission is the India's first dedicated solar observation mission, and yeah, the Aditya L1 mission, it is not developed any NASA, and the ISRO, it is not merged with, not collaborate with the ISRO and some Russia. There is no other institution of research. Only ISRO will be completely developed to study the solar behavior continuously. Okay, and as the it will be held at the satellite is held at the position of Lagrange point 1. It is approx 1.5 kilometer from Earth. You know, guys, the distance from the Earth and Sun is 150 million kilometer, and it is the Lagrange point is there, that is up 1% of the 150 million kilometer, that is 1.5 million kilometer. It is very near to the Earth but is very far from the Sun. You know, moon distance from the Earth is 3.84 lakh kilometer, and also Lagrange point is 1.5 kilometer. You got now, and that's it. Here, why it is L1 point is why it is crucial, because that point is very balanced, and very, yeah, that point is very balanced to hold that stay the satellite on that position, and but it will not attract to the gravitational force of the Earth, and in the same way the Sun, it will keep their balance at the points. And also major, why it is very crucial, it is no solar eclipse. Okay, the direct and uninhibited observation of the Sun without interference from the Earth's shadow. If this Lagrange point, okay, if satellite we keep here, okay, then sun ray will not directly fall on the here. Some When sun ray fall on the Earth, from this some shadow will be become, that though that disturbance is also not to there for that. That's why they keep in that's why they keep in the satellite in the L1. In the same one, in the next one, the continuous solar diagnostic means here, this point is here now. We can continuously observe what is happening here, and if we and someone we can early detect here solar eclipse, the solar eclipse, I means coronal mass ejection is happening or not, we can detect early as point. And then also we can better analyze this the weather, space weather, and also solar magnetic dynamics. Next one is, now guys, now it's solar payload division. It is also related to the Aditya L1. Okay, in that some different futures we read, that is a first solar dedicated missions, and it is placed in the L1 point, and why the L1 point is suitable we have studied. Okay, or some scientific payload, there are 7 sensors there. Aditya L1 is integrated with 7 high precision sensor. Okay, in those 7 sensor they categorize two group. The group A, that is remote sensing payload, that is there are 4 sensors there. Second group, here you can observe here, the group B, in-shoot payload, there are 3 sensors there. In that for one sensor there is a one work is there. They need to observe all the things of the what is the atmosphere of the sun, and what is the activities going in those around the sun. That's why, and first remote, these are remote sensing payload. In that first sensor, it will be visible emission line coronagraph. Okay, it will steady. It will what will do? It will steady coronal the solar corona. Okay, it is the outer solar atmosphere. Okay, and it will what examine what is it will it will try to find coronal heating mechanisms also, and coronal wind origin, and coronal mass ejection acceleration. It will study. Second one, it is solar ultraviolet imaging telescope. Okay, solar ultraviolet imaging telescope. Here, it will what will do? It will ultraviolet radiation profile to map the chromosphere and atmosphere dynamic, photosphere dynamic. Okay, in the same way, it will their work is to analyze solar ultraviolet radiation profile. In the same way, here solar low energy X-ray spectrometer measure low energy X-ray spectrum to dialing energetic solar flares. Okay, here X-ray spectrometer if X-ray spectrum need to study this. Okay, but it is very low energy, but some there is a high energy sensor will be there to to study X-ray spectrum. This also is there. Okay, you can go through it. You can go through it once. You can get know. And this is group B in-situ payload. It has three sensors, that is Aditya solar wind particle experiment. That is major property of solar wind particles. Solar wind particles, what are those? The proton and alpha particle and heavy ions. If you studied these in wind particles in the, if you studied graduation, you can get to know. Get graduation in the PSC. And plasma analyzer package for Aditya. It is plasma analyzer package for Aditya. Decipher the plasma composition. It will differentiate plasma composition and energetic electron. Okay, around the Lagrange point. Advanced trial axial high resolution digital magnometer it is. It will capture the magnetic field profile. Magnetic field, the magnetic property means some attracting nature, right? And surrounding the spacecraft, mapping interplanetary solar magnetism. It will some show the pictures interplanetary solar magnetism. How the magnetism means attraction happening in the planet. It can be have the some next here what is okay. Do you know, guys? Lagrange point. It is I said in Aditya L1 mission above. That is, it will balance. L1 point is balance to. It will never going to fall in the earth also and towards the sun. But it is not the reality in case L1. The L1 point is not perfectly stable. It has passive gravitational wave, and some fluctuation will be there. Okay, to overcome that, why um, the, the ISROs will preserve in payload. The ISRO will be reserve the fuel. If when satellite is go into the different direction, then thrust will uh, thrust will blow, and then again it will keep in the track. That's it, guys. It will help. Why it is instability at the Lagrange point? You can get to know. If anyone are getting taking different direction, we want to go this direction, anyone are taking different direction, then we have to take some charge now. That charge will take by a thrusting fuel. That's it. Now, guys, that is Chandrayana program. Okay, now we are going to study here Chandrayana programs 1 2 and 3 4 5 also. Here, Chandrayana first. Okay, Chandrayana first is launched 2008. Okay, it is launched through a rocket PSLV. Okay, it is orbiter alongside the moon impact probe. Just remember, it is orbiter alongside the moon probe impactor. And key milestone and major achievement of the Chandrayana first. It is the identify the hydroxyl molecule. It is discovered the presence of water in the moon. Okay, and it also okay, and it also help the um, some next human habitation on the moon. It will, if we find the water and it possible to live on the moon. That's why that is very, that will play a very significant in our discovery. Okay, Chandrayana played a huge role in our ISRO to reach our growth in front of the world. Okay, so it is moon, and you can know I already said you in the previous classes, but okay, it is lunar orbital in such a sequence. It is lunar from here to here like that. If it is one, that is translunar injection. If it went like this, but you can I am trying to say here only in 2 dimension, but you have to image in 3 dimensional. Okay, 3 dimensional is natural source, like natural environment between the earth and moon. Okay, some structural evaluation is there, like Chandrayana first or Chandrayana second, third. What are the, you don't want to go in the very deep of this Chandrayana program. Just remember the launch vehicle is the Chandrayana for first PSLV, and it is orbiter and lunar impact probe. Okay, this is the payload component has the orbiter, and it that rocket hold that orbiter and lunar impact probe. Okay, and it is also completely successful. Chandrayana 2, that is LVM3 and M1 rocket. It is orbiter, and then Vikram lander and Pragyan rover. Vikram lander and Pragyan rover, it will not, yeah, it is also a landing. It is also a, it mission is also a launch for the landing of the our rover. And okay, our payload need to land in the moon, but it is not happened. That arbiter is successful, because the moon orbit, it will, that rocket, that satellite is hold. Okay, and this Vikram lander and rover, this is not reached on the surface of the moon, and it is crashed. Okay, it is partially successful, that's why it is partially successful. And Chandrayana 3, it is our major milestone in our history. Okay, right? Because we are okay, first let me go here. It is launch vehicle is LVM3 and M4. Okay, it is payload component, it is propulsion module, lander, rover. Here no orbiter is there, but in first two, that is Chandrayana first and Chandrayana 2, orbiter is there. Just remember these difference to try to answer the questions. Okay, but no orbiter is there here. In Chandrayana 3, no orbiter. That what is there? Propulsion module and lander rover is there. It is completely successful, and we fully happy during the it's successful. It is completely land and successfully land on the South Pole, and we became the first country to land successfully on the South Pole. Yes, Chandrayana 4, 5 and Gaganyana mission. Okay. Now Chandrayana 4, you happen here in the news, okay, right? And it is one of the major, you have to know it. It is one of the major mission of the ISRO, and you have to know it. Okay, lunar sample return. Just remember, this mission is for lunar sample return. Okay, it missions will go to the moon and then land on the moon, and again take some soil or lunar samples, and then take off from that moon, and then again landing on the earth. Just you got what I am going to saying. Yes, right? And okay, for this, to go moon, to just assume it is a moon. Okay, to go moon and landing on the moon and return to the earth, that we required a heavy developed satellite, that is our highly developed highly developed satellite. So not satellite, sorry, that is launch vehicle is LVM3 launcher. Okay, it will with an orbital docking. Docking means, you know, right? After some point of time, the joining of two satellite or removing of satellite from two, not satellite, the launching rocket, launching vehicle. Okay, the launching, joining of the launching vehicle or removing of the launching vehicle by using the computer guide, that will happen in the space, that is the docking. Okay, and here we use the five modules in the to collect the Chandrayana sample from, to Chandrayana means to lunar sample from the Chandra. Okay, and first stage is the propulsion module, second stage is the descender module, third is the ascender re-entry capsule. What will be, first is the propulsion, it will take off from the earth, and then descender, and it is landing on the moon, and ascender, it is take off from the moon and also transfer and re-entry on the earth's surface. It is re-entry capsule. Okay, you can go through. And what is the, now you can got Chandrayana 4, right? Collecting some sample from the moon. Now Chandrayana 5, that is Lupex, it is giant venture. It is a partnership between the, I hope you get that Chandrayana 4. And now Chandrayana 5, okay, it is Lupex, it is a joint venture. Remember here it is a joint venture, that is between the ISRO and the JAXA Japan. Okay, the partnership between the ISRO and JAXA. JAXA Institute, JAXA Research Institution is belong to the Japan, and it is need to for the exploration of polar. Okay, the lunar polar exploration, and it will carry heavy sophisticated rover. It will carry heavy sophisticated rover, that is up to 350 kg or 350 kg it will take on the moon. Okay, to detect and quantify the surface, subsurface water ice. Wow, it will detect the subsurface water ice. The water means like some any other bodies there are not in the water bodies there are not in the moon, they are doing that. Okay, I hope that also clarified. And now Gaganyaan, human space flight program. You know it is human space flight. Okay, designed to send a Indian astronauts into the low earth orbit. Just remember where need to send the man, means human being, in the low earth orbit using the human rated launch vehicle designed at HLV-M3. Okay, I hope you can read here, you can get to know the more information. And okay,